Hello, my name is Maria, and today we're going to talk about nodal analysis in ECE3300. So, nodal analysis is basically just an application of Kirchhoff's current law, and Kirchhoff's current law is the sum of current that comes into a node is equal to the sum of the current that comes out of a node. And the next question you would ask is, what is a node? And so, on this circuit here, a node would be here and here, and that's because a node is anywhere on a circuit that two or more branches are connected. So now I'm going to go walk through the steps of nodal analysis and how we can find nodal voltages and things like that. So the first thing we're going to do is choose a ground, and basically what that means is we're going to choose a reference area that we want the voltage to be 0 compared to the other ports. So let's just put the ground right here for now. Again, I said this voltage equals 0 down here, which means that the voltage up here, like up here, is going to be higher than the voltage down here because that's a 0. Okay, after we've chosen our ground, we're going to be differentiating between the different nodes we have. So you can see that I've already marked down the nodes that we're going to be looking at. Let's just label them V1 and V2. Okay. So after we've done that, we're going to start to look at the currents going through the circuit, and we're going to try and figure out the directions that these currents are going. So starting over here by the 10-volt battery, we can see that the positive terminal is up here. This means that the current travels from the positive to the negative, so it's going to be going like this, which means that the current is going that way into V1, into that node. Okay, which then that means that since the current's going like that, we can just assume that it's going down from this node. And then looking at this other side with the 2A here, that is a current source, which means that we already know what the current is, and we know which direction it is. So we can say it's going this way. So we can say that the current there is going into the node and then also coming out right there. So the last current that we don't know yet is in between here with this 2 ohm resistor. And for that, we're basically going to guess, because if we're wrong, that just means we're going to get a negative answer, and that means that the current's going to be going in the opposite direction of we guessed. So assuming the current is good, and it's sometimes necessary to solve these equations. So just assume that it's going this way. So that means it's going out of V1 and going into V2. So once we've assumed the current directions, we can start to apply Kirchhoff's current law at each node. So let's start looking at node V1. So let's do V1. The Kirchhoff's law, we can see, is the current coming in is equal to the current coming out. So let's just say that going in is going to be positive and coming out is going to be negative, okay? We can see that this one right here, let's label this. Let's go back and label all of them just for fun. I1, let's do that. I2, I3, and then I4. And I'll get back to that one in just a second. So let's look back at node 1. Okay, we can see that the current going into it is just going to be I1. We can see that the ones coming out of it, obviously that's a positive, and the ones coming out of it are I3 and I2. And those ones are going to be negative, and that's going to be equal to 0. We could also have written it like this, but that doesn't really matter. Oops. So we have these equations here with the current, but the question is, how do we get these currents? What does I1 really mean? So we can go back and look. And current, we know, is defined as the voltage on the positive terminal minus the voltage of a negative terminal over the resistance. And what does this positive and negative terminal mean? Basically, it means that it goes in the direction, like the positive and negative goes in the direction of the current. So if this is the current, then the positive side is over here and the negative is over here. And this is called passive convention. So why don't we just go through and label real quick the passive convention for all of these resistors and currents so that we know and we don't mess anything up. So we can see that this arrow is going this way. So we're just going to put a positive here and a negative here. Again, we can see that it's going this way. We're going to put a positive here, a negative here. And a positive here and a negative here. And a positive here and a negative here. Okay. Now let's look at I1. So for I1, we can see that the positive voltage is going to be this 10 volts because that's connected to the positive side of that resistor. So let's see, I1 is equal to 10 volts minus the V at the negative terminal, which is going to be V1 right here. So let's do V1, and then it's going to be over that resistance of this resistor, which is right here. And we're going to call that 1, obviously, 1 ohm. So, oops. Okay, and now let's look at I2. We can see that I2 is equal to the positive terminal, which is again going to be V1, and then minus the negative terminal, and that one is going to be V2, minus V2. And then over that resistance, which is going to be 2 ohms. Okay, and then I3 is going to be equal to, at the positive terminal, we have V1, and at the negative terminal, we have this ground, which is 0. We see that that's 0, so that means it's V1 minus 0, which really means it's just V1 over 5. Okay? Let me just reorganize this here so that we can have some more space. Okay, so now that we have I1, I2, and I3, we can plug this in to that first equation that we had there in blue and get, we can get an equation for V2 in terms of V1. So let's just go ahead and do that. Let's say I1, let's write that down, I1, 10 minus V1 is equal to I3 plus I2, which is V1 over 5 plus V1 minus V2 over 2. Okay, let's just get rid of the fractions here just to make things simpler. Let's multiply this by 2 over 2 and this by 5 over 5. We're going to get 10. Oops. Okay, and then after we do that, we're just going to multiply this whole thing by 10 and this whole thing by 10. Okay, so what we're going to end up with is 100 minus 10 V1 equal to, after combining some things, we're going to get 7 V1 minus 5 V2. Okay, and then once we solve for V2, we can get that, V2 is equal to 17/5 of V1 minus 20. Now this is really good because now we've established a relationship between V1 and V2. I'm going to label this equation number 1, and we're going to come back to that. But now we're going to do some nodal analysis at V2. So let's go back to V2. And first of all, we're going to look at the Kirchhoff law. We can see that at V2, we have I4 coming out and I2, and then this arrow here, right here, is actually this 2 amps. So we can see that this is just 2 amps here. and we can see that this equation then becomes I2 plus 2 is equal to I4. Okay, and that's going to be important again once we solve for these currents. Let's look, I2, we already know what that is, but we can just rewrite it. V1 minus V2 over 2 ohms. Okay, and then I4, one that we haven't done, we can see that the positive terminal is V2, and then the negative terminal is 0. So we can basically say that I4 is equal to V2 minus 0 over the resistance, which is going to be 10 ohms. Okay, and once we do that, we can just plug that into our Kirchhoff law equation. We can see that V1 minus V2 over 2 plus 2 is equal to V2 over 10. And just to make things easier, we can simplify this really quick. We're going to get, let's multiply this by 2 over 2, and then multiply everything by 10 to solve for V2. Basically, we're going to get 2V1 minus 2V2. Oh, I'm sorry. I don't know why I did that. Okay, let's multiply these both sides by 10. Okay, we're going to get 5V1 minus 5V2 plus 10. Oh, sorry, 20 is equal to V2. And then we're going to put the V2s on that side. We're going to get 6V2 is equal to 5V1 plus 20. Okay, and now we can see that this is really cool. We found a V2, and we can just plug these back in using substitution. So using equation number 1, we're going to get, let's see, 6 times 5V1 minus 20 is equal to 5V1 plus 20. And now you can see we've just eliminated one of our variables, and now we can solve for V1. Once you solve for V1, you'll basically get that V1 is equal to 9.091 volts. And then we can go ahead and plug that back in to this equation here, and then we'll get that V2 is equal to 10.909 volts. Now, the good thing is that once we find these nodal voltages, we can basically plug that back in and find any current running through this entire circuit using these equations up here and these equations here. So let's just try that. Let's solve for I1. As we solved for before, we said I1 is equal to 10 minus V1 over 1 ohm. So now that we know what V1 is, we can just plug that in, and we'll end up getting 10 minus 9.091, which is equal. We can see that this is equal to 0.909 amps. And so basically what that means is that the current running into here, into this voltage here, is 0.909 amps. So just to recap, let's go over the steps that we need to take in order to perform nodal analysis one more time. So first, you choose a ground, right? And what that did was allowed us to make a reference point at which somewhere where the voltage was equal to 0. Once you've chosen a ground, the next thing you do is to label your nodes, right? That's when we label them V1 and V2. And then after that, you're going to find and label your currents that are going through, right? Like I1 and I2, you're going to first find those, assume their directions, or like if you know that, you're going to make it, If you don't know that, you're going to make a guess, but if you do know, you're just going to put that direction. So you're going to find and label the directions of each current, right? And then after that, you're going to apply Kirchhoff's current law, KCL. You're going to apply KCL at each node. Right? And that's what we did here. At this part right here, we applied it. And then using this formula right here, we could find what the currents actually were and then relate that back to terms of our nodes, right? So that's the fifth step, is to write the currents in terms of your nodal voltages, right? Remember, that was I equals V at the positive terminal minus V at the negative terminal over the resistance. And finally, you're going to use substitution to solve for the two variables. And maybe if there's three variables, so if there's three variables, you're going to use a matrix to solve these. But that is basically the steps for nodal analysis. And using nodal analysis. But yeah, basically with these steps, you'll be able to solve any problem, and I hope that helps. Thanks for watching.